right, good afternoon, everyone, and welcome to the unit kindergarten point one, energy sunlight. On our overview today here at Open Syed, my name is Janita Vasquez. I am the program manager for elementary development here at Open Syed. And joining me today is Gail Hausman, who is the Senior Curriculum Development Specialist for Northwestern University. Gail is also the lead writer in this unit, so we are glad to have her here today. Also joining us are my colleagues, Sarah Delaney and Erica Frazier from Open Syed. Sarah and Erica will help us today to answer questions in the chat or in Padlet, will help us navigate slides and let folks in the meeting. So you may see them in the chat today. So we're glad to have them with us. Okay, so let's get started. Let's give you a little bit of a snapshot of what our session will look like today. So I'm going to give you a little bit of background on Open Syed Elementary and what that looks like. Then Gail is basically going to take over and she's going to help us experience a little bit of our unit. She's going to walk us through our lesson one or our anchoring phenomena unit so that you can experience what your kids will experience in the classroom when you start instruction. So you have a good idea of what that first lesson looks like. Then Gail is going to take a little bit of a step back and help us walk through the storyline for this unit. So that is all 10 lessons for this K.1 unit so that you know where this unit begins and how it develops and then how it ends. And then she's going to share some exciting things about this unit. We asked her to find the things that she just loved the most and wanted to highlight for you. And then we're going to spend some time answering questions. And we hope to answer as many questions as we can. So, all right, so today we're going to be using Padlet as a way to help us communicate. And there is a link that Sarah will share in the chat. But there are some sections in Padlet I'm going to show you in a second. And you can add in your question or comment having to do with these things. Do not worry if you're not familiar with Padlet, if you're not comfortable with using Padlet, please go ahead and use the chat feature and drop down some questions, comments. Gail may have some questions for you that she'd like you to answer in the chat. So either Padlet or the chat will work today. And again, we will answer as many questions as we can. And one last thing is that this webinar is being recorded. So if you have friends that didn't catch it today, or you need to go back to watch again to look at specific things and great stuff that Gail is going to share with us today, you'll be able to do that. Okay, so let me tell you a little bit about our Open Syed elementary program. So Open Syed is a nonprofit organization that brings together amazing, wonderful curriculum developers, state science supervisors, teachers, and philanthropic organizations, to help develop free, high-quality science materials and professional learning for those instructional materials. We have already done this for middle school and high school. If you're not familiar with our materials, our middle school materials are out in the world, rated green by Ed Reports. High school materials were completely released earlier this year. And now we're working on elementary, which of course is the one I am the most excited about because that is my world. And like I said, we bring together state supervisors, but those 9 state partners have helped us to really think through, give us feedback, field test these units. So we've had over 450,000 teachers that have field tested and are currently field testing our materials with about 10,000 students in 9 states across the country. So we are grateful for their participation always. They give us fantastic feedback. And then a few more things about elementary. Sorry, my computer is being very touchy today. So first thing, our units are designed for flexible use in real classrooms. For our kindergarten program, we have 4 units that will encompass the whole year. Today we are talking about K.1. And while we have a recommended sequence for these units, we also know that you work in special places all over this country, in special contexts with special populations of students, and you know best. So while we have a recommended sequence, this is designed to also be modular, so you can decide, make decisions about what will work best in your classroom. Now, so when we say flexibility, we make this so that you can actually teach it in your whole school year. So what we know about kindergarten is that depending on whether you're in a half-day kindergarten school or in a full-day kindergarten school, you can have anywhere between 36,000 and 50,000 instructional minutes in a school year. And we have 4 units with each 10 lessons each. And each of those lessons is 60 minutes. So that comes to about 5 to 7% of your instructional year. That is very little. So this is definitely manageable. Now, just let me say one thing about those 60 minutes per lesson. We are not expecting that you as kindergarten teachers are going to do science for an hour straight. Our units are designed in really manageable chunks that you can think about how they work best during your school week and during your school day. So if you have 20 minutes for science a day, you can make that work. If you have 30 minutes for science 2 times a week, you can make that work. Our units are made that way because we know we are designing for real classrooms. Okay, and one of the things that we are really proud of is the integration that we've done when we've designed these units. But we've worked really hard to integrate mathematics and ELA into the design of the units. As far as math integration, we are really focusing, first of all, math practices. Of course, you are going to see those math practices integrated into science. But we are also focused in using math talk, math modeling, to really make sense of data and share findings and explanations. And that's even at the kindergarten level. That is even from kindergarten to 5th grade. Okay, so we are really proud of the math integration and always the mathematics in the service of the science. Then literacy integration, again, super important. We are really excited about the things that we've developed as far as ELA integration into our materials. We are helping students to engage with multiple types of texts, and they are able to communicate their scientific thinking in a variety of ways. That means that we are looking at communicating orally and in writing, using gestures, using pictures and images, and sometimes using students' home language in your classroom as they communicate and build those skills. Our materials are meant to be hands-on. Your kids are meant to be doing the science, not just learning about the science. So please know that we are currently working with kit providers to eventually, hopefully by January of next year, have kits for purchase for our materials. Now, if your school decides that purchasing kits is not something you want to do, we also have the lists of materials that we use in case you all want to purchase those on your own. Okay, this is completely up to you how you all at your district level want to do that. You can have more information about that on our website. Now, I'm done talking, and now we get to do a little bit of kindergarten lesson, our phenomenal lesson 1. And Gail is going to help us do that. So Gail, tell me when to turn the slides in. We'll get started.
Thanks. Excited to be here with y'all today. Thank you for joining us. I'm going to give us just a quick introduction to the schoolyard engineering unit and the things that we're going to be doing in this unit, and then we'll jump into that lesson one, like Janita said. So this unit has 4 performance expectations in its bundle. 2 of those are physical science and 2 of those are engineering. I'll read them out loud just in case somebody's listening in and not watching the video right now. Kids are going to make observations to determine the effect of sunlight on our surface. Kids are going to use tools and materials provided to design and build a structure that'll reduce the warming effect of sunlight on an area. And then this is an engineering design unit. So we have asking questions and making observations and gathering information about a situation people want to change to define a simple problem that can be solved through the development of a new or improved object or tool. And also kids get to develop a simple sketch, drawing, or physical model. We'll actually do all those to illustrate how the shape of an object helps it function as needed to solve a given problem. Those 2 engineering PEs are also addressed in the 3rd kindergarten unit in the sequence, which you'll get to hear about later. But we have those 2 engineering units, and this is one of them in the sequence. Thanks. In this unit, we are focused on 3 science and engineering practices specifically that we are intentionally developing with kids. They are going to work really hard to plan and carry out investigations. They are going to analyze and interpret data, and they are going to not so much construct explanations, but definitely design solutions. As we said, this is the engineering focus there. They will use other practices as well, but those are the 3 that we are really focused on in this unit. And then we intentionally developed 2 cross-cutting concepts as well. So this unit focuses heavily on patterns and cause and effect. Those are 2 of the most foundational cross-cutting concepts that we see throughout the entire K-12 program. So makes sense to start here in kindergarten's first unit with those 2. So I'm going to ask you right now to think back, remember yourself as a kindergartner. Think about what you did and thought at age 5. And we're going to go through this first lesson together, thinking about what kindergarten kids would be saying, thinking, wondering, questioning, as we explore these ideas today. And I will say, we're not in a classroom together. Generally, we'd be able to talk to each other. We'd be able to see each other's gestures and be able to point to drawings and whatnot, all the different ways that kindergartners express themselves. I'm going to ask you instead to use the chat. Like Janita mentioned, when I have a question that you'd like to respond to or you have ideas to share, I'm going to ask you to type that in our meeting chat today. So obviously that's not the way we have kindergartners share their ideas, but for our time together, we'll be thinking like kindergartners, imagining yourself as a kindergartner, but still writing your ideas in the chat. So you can go ahead and give us our first slide, Janita. And I want you to take a look at some of these photos. These are pictures of outsides of schools, because today in our science class, we get to go outside. And we're going to be scientists outside. Scientists explore the world around them to try to figure out how it works. And we are going to go outside today, go outside our school building and try to explore how different things feel. So if you have a picture in your head of your outside, those are some pictures you can think about. Take a look at our next slide. Got a few more pictures to share here. These kids are outside, right? And they're exploring the world around them. I'm asking you to think and look, notice what these kids are doing. And then you can share in the chat, what do you think these kids are feeling? And as you're thinking about what they're feeling, do you think the places they're feeling feel warm, or any of them might even feel hot? I see some emotions that people are sharing in the chat, and that is something we talk about in kindergarten, is the fact that when we talk about feelings, we might mean feelings like our emotions, feeling happy, sad, joyful, or we might talk about feelings like things we can touch and what we sense. So some of those things might feel rough or wet. Thanks. Maybe it feels soft. I'm curious about whether you think any of those things might feel warm or hot. I see somebody says cool. Somebody's saying that it might feel warm in the sun. There's such good descriptive words happening. Oh, the sand might even feel hot, we think. Okay, so my next question is, do you think these kids are feeling all these things in the same exact way? That every kid who feels what they feel is feeling the same exact way? I'm seeing no. We don't think so. Different people are going to think differently and feel differently about these different things they're touching. And do you think the things they're touching would always feel the same way? Like if they went out and they touched those same things later today or tomorrow or next week, would it always feel the same way? I think I'm still seeing some no's. Yeah, that something might change about the way that it feels. It won't always feel the same way. So we're saying that like there's some possibilities here that this maybe the grass isn't always going to feel cool, the sand isn't always going to feel warm. And when we talk about how things feel like this, it helps us talk about how they're different. Being able to say this one is different than this one helps us kind of compare those things, right? So somebody might say, well, this one feels hot and this other thing feels hotter. Somebody might say, this one feels warm and this other one feels less warm. And those are ways we can talk about how to kind of compare how things feel. Because there are so many different ways, I'm looking at all the different ways you said things can feel. It's going to be hard for us as a kindergarten class to think about all those different ways. There's just so many different ways. So today, when we go outside, we're going to look and think and feel, do things feel hot or less hot? We're going to look at those two kind of choices. When we feel things outside today, when we're exploring scientists, we're going to say they're either hot or less hot. Janita, if you go to our next slide, I will show you while we're working as scientists today, we're going to have a paper that we're going to record our ideas on. When we're noticing things outside, we want to remember what we noticed so that we can talk about them when we come back in and compare with other scientists in our class. So I will give you a clipboard to take outside with you, and I will give you this paper. And when you're outside, you're going to draw pictures in those boxes of the things that you feel. So you're going outside, you're exploring our schoolyard, think about some of the things you saw in those pictures that you could touch while you're outside. What can you feel? Draw a picture in one of those boxes. And then you'll notice there are some little icons up there. The red one says hot, and the blue, barely kind of colored in blue one says less hot. So you get to circle one of those choices. So for each thing you feel, you draw a picture, and then you're going to circle whether it feels hot or less hot. And because we only have those two choices, you might be circling hot for something that feels like pretty hot. Like maybe it's just warm, but you're like, oh, it could count as hot, sure. And you might be circling less hot for things that like are just not warm, even if they don't feel cold. It might not be cold, it'll just be less hot. So you're gonna circle one of those choices for each of the things that you feel. Janita, if you give us our next slide, we'll look at directions. So just to review, our directions when we go outside are that you will have a partner that you can talk about this with, but everybody gets their own paper, everybody gets their own clipboard and pencil, and you'll go outside and the first thing you do is find something to touch. What are you going to feel to see if it feels hot or less hot? And then draw that on your handout, circle hot or less hot for that thing. And then talk to your partner and tell your partner what you noticed and listen to what your partner noticed. If we actually got to go outside today, we would also take some time right now to review directions for how we're going to go outside safely, how we get outside the building, what our boundaries are while we're outside the building. If there's anything that we need to avoid touching while we're outside the building, we'll share those directions to make sure we all know what to do when we get outside. Now, as I said, we don't actually get to go outside. I'm sorry. I wish I could take all of you outside. Just wasn't sure how to do that virtually. So I want you to take a minute. You can look at the pictures that are on the slide and or think to yourself about a schoolyard that you're familiar with. So think about school you attended, a school you might work at, something that you have association with in your neighborhood, right? Think of a school and imagine what you might feel. I'm going to ask you not to hit go in the chat yet. We're going to do something called a waterfall, where I'm going to ask you to share what you notice, what you think you might feel when you're outside on the playground, but don't hit go yet. So don't share quite yet. I'll stop talking for a minute and let you imagine yourself as a kindergartner. Imagine yourself outside on that playground, outside on that schoolyard. What would you feel? And do you think it would feel hot or less hot? So we'll look for what's the thing you felt and did it feel hot or less hot? And hold your enters for the moment. I'll pause while you think for just a minute. think folks are starting to get some ideas because I saw a couple jump into the chat. So I'll go to the next slide, Janita. And if we were in the classroom, we'd be able to do this by moving around the room a little bit. But again, we're just, doing this here as we can. So go ahead and hit enter. If you haven't already, hit enter so we can see what you're thinking that you would have observed outside. And I'm going to read a few of these out loud just so that we have some examples to think about. Some of the things we thought that might feel hot were things like a bench. Maybe the black ground feels hot. A swing seat might feel hot. The slide might feel hot. People are saying maybe the grass feels less hot, or somebody else said the slide they felt less hot. We have some ideas that maybe a tree that I might feel would be less hot. These are great. Thanks for sharing. I appreciate you all picturing your schoolyard so we can share these ideas. The grass would feel less hot. Oh, gravel. If I have gravel on the ground, that might feel less hot. Oh, there's a wall in our school that's brick, and that brick might feel hot in some places, but if I maybe feel it somewhere else on the building, it might feel less hot. So that's interesting. Okay, thanks. And I'm just thinking while we're listening to me talk about all these things, were any of those places that you could have imagined feeling, and think about, like, did you also think it felt the same way? Or maybe you didn't. Maybe you thought that that was different. And we can kind of use some of that comparison language. Did we think so? Yes, no? Do we agree, disagree? Do some thumb ups, that kind of stuff while we think about sharing these observations. Now, these are great observations, and we want to be able to keep track of them and record them so that we can do some work thinking about them. So Janita, if you go to the next slide, we have a chart in our classroom, and our chart is a notice and wonder chart. So a lot of the things that you all just shared in the chat, I would write on this notice chart. We noticed a lot of things about how things were hot outside, what things we felt hot, what things felt less hot. And while we're talking about those things and sharing those things, I also want us to write our questions too, because questions are super important to scientists. Scientists use their questions to do all their work of figuring out. So we're going to think for a minute about some of the things we noticed and what questions that we might have. So think about those things that you thought were hot and what your classmates said felt hot. Where were they? Were all the hot things in the same place? And you can go ahead and jot a note in the chat if you'd like to. Where were the hot things? And were they all in the same place? Some of us might be noticing that maybe if things were like in a sunnier place, that they might have felt hot. Seems like we're hearing that from a couple people. And I wonder what questions you have about that. What are you wondering about that? Like, are things always hot in that place? Are they always? Yeah. And then take a minute to think about the less hot things. Think about the things you said were not as hot. Were they always in the same place? What wonders do we have about where those less hot things are located? And then I also want you to take a minute to think about when you are at home or at a different place that's not our schoolyard. Have you ever noticed that things feel hot or less hot outside? Have you had other experiences where you were outside and something, like, you noticed that something felt hot? Or you noticed that something was like not as hot as you expected maybe? Think about some of those other times that you've been outside and noticed hot and less hot things. Oh, I'm seeing somebody says, oh, when I get in the car feels hot. I have also had that experience, Gary. Oh, standing on pavement is hot. That's an experience that I think a lot of us in this class have had. We were waiting outside to get into the school building. It might feel hot and we're standing outside. Oh, interesting. Dustin mentioned that when he walks onto the grass, it always feels a little cooler than the rest of the ground. Oh, Gary, good call. If you're sick, you might feel hot when you're sick. Yeah. Oh, and if you've had a chance to go to a beach or a place where there's sand, the sand seems to feel hot. Thanks for sharing those experiences. So we can add those noticings to our notice board as well. And again, as we're thinking of questions about this, we're going to add our questions to our questions, that wonder side. And since I don't have a chance to write this all down for you, I'll share with you what some kindergartners said. So Janine, if you go to the next slide, you all can see an example here of things kindergartners shared. So some of the noticings they had were that some things were in the sun. They noticed things were in the sun. And somebody asked, well, why are some things not in the sun? Why are some things in the sun and not in the sun? They noticed that some things were in the shade. And they wondered, why are there trees all over? Like they're noticing around our schoolyard, we have trees all over. Why is that? We noticed that some things felt hot. Like there were things that we noticed that felt hot. And we're wondering, why are they hot? We noticed that some things were not so hot. And we wondered maybe the monkey bars are one of those things that are less hot, maybe. And we did also notice that it felt less hot when we were inside. So inside things felt less hot to this group of kindergartners. And I want us to think about the fact that scientists often use certain words that help them talk about exactly what they saw or did. So as we're talking about what felt hot and less hot to us, I'd like to share a word with us that can help us talk about exactly what we felt in our schoolyard. So think for just a minute about some of the things that you felt. I heard somebody saying they felt the wall of the school building. And when you were feeling the wall, did you feel the inside of that wall or did you feel the outside of that wall? And I'm going to go ahead and assume that you felt the outside of that wall. And I heard somebody else say they felt a tree. So when you felt that tree, did you feel the outside of the tree or the inside of the tree? I think the outside of the tree. Yep, I'm seeing that in the chat. Thank you. Somebody else felt the blacktop. And like when you felt that blacktop, were you feeling the outside of the blacktop or the inside of the blacktop? Seems like that's the outside too. So generally, I hear us saying, usually we are feeling the outsides of things. And I'm going to share a science word with us that we can use to talk about the outsides of things. It's the word surface. And I've got a cool text that we can use to help us understand what a surface is. So Jeanette, if you flick the slide, I've got this text here that's called an infographic. And we may or may not have seen infographics in our class before. Sometimes they're like around our school building, but an infographic is a type of text that has words and pictures to help us understand what they mean. And so I'm just going to read this infographic to us. It says, what's a surface? A surface is the outside of something. Surfaces are everywhere. There's a rock, a chair, a leaf, a lamp, ice cream, dirt. Those surfaces are everywhere. And we can think, how do we think these surfaces feel? And you can just think that in your head. Think about that question in your head. But I'm also thinking as we're looking at this infographic, it says that a surface is the outside of something that we can feel. Where you're sitting right now, can you feel any surfaces? Like what surfaces can you feel? I can feel the surface of my computer. I wonder what surfaces you all can feel. Maybe my chair, I can feel the surface of my chair, feel the surface of my desk. I might have somebody sitting on the carpet and we could feel the surface of the carpet. We can even turn and share it with a partner about what we feel, what those surfaces are that we're touching. And I just want to clarify with us, when we went outside into the schoolyard and we were feeling things outside, that kind of outside was like we went out in the fresh air, we went like not indoors, we were outside the building. So think for a minute, like that's a different kind of outside than we're talking about the outside of something, right? This is a word that has two meanings. And so I can use the word outside to talk about a thing or a place that I can go that's not outdoors. Do it either way. So we're going to add the word surface to our word wall so that we can keep using this word to talk about the things we're doing in science. But now we get a chance to say, okay, we've got our notices and wonders. And Janita, you can flip to the next slide, back to our notice and wonder chart. And we've got that word surface in our heads to think about the outsides of things that we can feel or touch. And we know that when we're working as scientists ask questions about the world and then try to go figure out the answers. So we get to work on trying to figure out the questions that we have here on our notice and wonder chart. And I noticed that a lot of our questions were about things feeling hot, and like then other things felt less hot. And we were wondering like why that is. Why do these things feel hot and these things feel less hot? But we have that cool word surfaces to describe what we were feeling about them. So it seems if I can combine our questions into like one big question that we'll try to work on for the next little while in science class, the one big question that we can try to work on is, why are some surfaces hot and others are less hot? Why is that? So when we write that on the top of our chart, Janita, if you flip to the next slide, you can see that I even have some pictures I can put here to help us remember that surfaces are the outside of something, and then things are hot or less hot. Janita, flip back just one slide, because I just want us, before we get to ideas for investigation, let's think about what ideas do you have right now about why you think some surfaces are hot and others are less hot. Like we had some ideas maybe while we were noticing and sharing our noticings. So if you have an idea right now about why you think some surfaces are hot and less hot, you can write that in the chat. And it's totally okay not to know. Should clarify. This is a question we're trying to figure out. I'm just wondering if anybody has any ideas to start us off. But if we don't, that's okay. Totally okay to not know why. We're going to try to figure this out. But I see people proposing in the chat that maybe why some surfaces feel hot and less hot has something to do with like what they're made of or what color they are. I'm remembering before in our discussion, we were talking about like where things were, and some people mentioned that like maybe it has something to do with sun or shade. We had some ideas already about like why we think things might feel hot or less hot. So now you can flip our slide, Janita, because scientists like us really like to make a plan for how we might be able to answer our questions. So knowing what you're thinking, what could we do to figure out why surfaces feel hot in some places, but not as hot in other places? Where do you think we might need to go? Like think about some of those ideas on our notice wonder chart. What could we do to figure out our questions? Where might we need to go? See some people suggesting that maybe it has something to do with the sun. And I remember somebody mentioned the shade as well. We thought maybe somebody said it had something to do with maybe different materials, like what it's made of. So we might need to go explore that a little bit more. The sun doesn't shine very much into our classroom. So I wonder if we might need to go, somebody else was on the same line of thinking I was. I wonder if we might need to go outside again and look into some of those different areas, look at some different places and look at those surfaces again and feel them in those areas to see if they might be feeling different, if they're like in different places, sun, shade. That might be something we want to do next. We don't have time for that today, but we can explore that next time. That feels like a good place for us to go when we get to do science again. That's where we're going to leave it for now. So thank you for participating as kindergartners. That was awesome.
Thanks, Gail. And yes, thanks everyone for participating. And I know there was one question, Sarah. I saw a question earlier on. It was a couple.
Yeah, I had two that I want to elevate. One was you kind of alluded and like kind of touched on it a little bit, Gail, but I think now that we're out of the student experience, there's a question of how would you handle responses that are about their physical feeling versus their emotional feeling? So that happened kind of right off the bat. People were thinking, oh, I feel joy and happiness. So curious what's in the materials and like kind of written in there to attend to that, or what would you recommend in general?
You bet. There's a specific move in lesson 1 that has teachers, I forget if it's like right in the text or if it's just a call out, that says, teachers, when that happens, because we know it will, talk about the fact that feelings, like when we talk about feelings, that is one of these multiple meaning words, right? Multiple meaning words is one of our connections to ELA, and there's a standard about that, that we can think about this word feel as two different ways to, like, we're talking about our emotions or we're talking about things we can touch and feel. And so we just, like I did a little bit, you can do better with your own students, but to just acknowledge it and be really explicit about it and continue talking about that as you go through the, what kind of feeling are we doing right now?
And then we're turning is what I think we saw you do, and you would experience it even more if we were actually experiencing the unit. You're turning from, yes, your experience is valid and I feel joy too. And that is definitely feeling. Now we're going to talk about like tactile feel, like with temperature. And so then the unit follows that trajectory.
Exactly. Yeah. And we can certainly continue to acknowledge how we feel emotionally, but the noticing that we're doing as scientists with this particular question we're trying to answer about going outside and how things feel outside is like the things outside. And we can focus on that part of it, is like, we're going to go touch actual objects and see how they feel. And it's not the emotional side at that point.
Great. The other question was a question about, is there a recommended outside temperature to conduct these experiments so that students can feel enough of a contrast?
That's a lovely question. We did not test specific temperatures, but there's a reason that this unit is first in the sequence. There are several reasons this unit's first in the sequence, but one of them is so that this is something you could do outside during milder temperatures. It would be harder for kids to feel that difference if it was very cold outside. We want the sun to be able to act well on the various things they're feeling. So we want it to be pleasant outside when they go outside as well. I'm gonna tap Amber. Amber Bismack is here as well, and she worked on the precursor to this Open SciEd unit, was a solid start unit from the MSU team, and they had a lot more experiences in Michigan with this kind of thing. So Amber, I don't know if you have other ideas about recommended temperatures. I will say there's guidance in the teacher guide that's like, you're obviously going to go plan for where your kids are going to feel things. And if you know there's a place that's going to be like super windy, kids often get confused about like the wind, automatic, like wind chill, right? Makes us feel colder. And so that's like a little harder to deal with. Amber, I'll stop talking and see if you want to share anything.
No, thank you, Gail. You touched on all of it. I think being in Michigan, we were able to test this out more in those warmer temperatures, which is again why it's first in the sequence. The other thing I'll just add is that when talking about the kit, we do also suggest having a heat lamp in case you aren't able to go outside, so you can still at least be able to test this out in the classroom as well. So that provides another opportunity for children.
Thanks. I totally forgot that was something we had in the kit list. Yeah, so it's included when you order a kit from the vendor, it'll come with more than one, because our field test teachers only had one and they were like, that is not enough. So a couple heat lamps so that you can recreate, surfaces that we could have with the heat lamp representing the sun. And there's guidance in the materials about how to talk about this heat lamp as being like the sun at this point. Yes, good call. Thanks.
Great. Anything else you saw, Dale? I mean, sorry, Sarah, as far
I
as
was not watching the
I didn't see
chat.
anything else.
No, I think we're good. I think we can start going. I would encourage people to continue adding to either the chat. There's nothing in the Padlet right now, which is fine. But we can start going through the unit, and I'm sure that more questions will come up.
So now we get to start talking about the storyline. So Gail is going to walk us through that for a little bit. We get to talk about each one of the 10 lessons in this unit.
Fantastic. All right. So we all did just experience lesson 1. Oh, your poor computer.
Sorry, Gail.
No, you're totally fine. All good. In lesson 1, like we experienced, right? Kids actually get to go outside and make direct observations of things in the schoolyard. And we figure out that some things feel hot and some things feel less hot. And we raise our questions about that, why some things are hot and less hot. And we decide that we want to go outside again, right? Our navigation into the second lesson is like, oh, we need to like be a little bit more, thoughtful, right? And plan a little bit more about what we're going to feel outside and where we're going to feel things to try to answer this question. So then in lesson 2, we get to go outside again And this time we are focused on, we think there's something different about what we're feeling in sunny places and shady places. So we have a different handout. Once again, same procedure with my clipboard and my handout, and I get to do this myself, but I'm going to talk to a partner while I'm outside. Draw something that was in a sunny place and circle whether it was hot or less hot. Draw something you felt in a shady place and whether it was hot or less hot. And so we're starting to, again, make those observations. And then when we come back inside, we compare our observations and we're starting to look for patterns. So as I said, the cross-cutting concept of patterns is huge in this unit. And it starts in lesson 2 where we're identifying, we name the word pattern in lesson 2, and we start to look as we combine our class data. There are a couple different ways in the lesson that the class compiles their data together, and then talk about it with a partner to start finding a pattern. Oh, we're noticing that most of the time we think we see that sunny places have more hot surfaces and shady places have more less hot surfaces. And so we identify that as a pattern. The definition that we use in the unit is that a pattern is something that happens over and over again and can help us can help us know what comes next. And so we're thinking, okay, we're pretty sure that like the sunny places had more hot things and the shady places had more less hot things, but we're wondering now if that could help us know what comes next. Like, are there other surfaces or other materials that would follow that same pattern? So that's how we get into lesson 3 then, when in lesson 3, the teacher's like, okay, we wanted to check some other surfaces and see if our pattern held true. And so the teacher says, okay, I've got sand and dirt, and we take a pan of several pans of sand and pans of dirt, and we put some of them in the sun and we put some of them in the shade. And then we go make our observations again, touch each one and see how they feel. We're careful to compare the sun to the sun, sun to the shade for the sand, and then sun to the shade for the dirt. This unit does not, I saw some of our comments earlier in the chat about colors and whether the color is having something to do with it. We're not going there in this unit. So we don't have the kids compare like the sand to the dirt. We look at just same material in sun and shade. We also in lesson 3 get to read a book about other kids' experiences. So this is one of our In Our Communities books where other kids are describing what they have experienced with surfaces near where they live. So it helps us expand again to more surfaces other than what was in our schoolyard. They talk about rocks and water. So we get to make these observations in lesson 3 with a partner. We're doing that work outside, but we haven't, at the point in lesson 3, there's just not enough time in all the lessons to combine our data yet. So we're like, okay, we think we see this pattern holding with my partner's data, but now let's combine our data as a whole class. So in lesson 4, we do some more work with this data analysis, and again, supporting the kids individually and as a class with combining this data. So lots of chart work that we're doing, and there's different colored checks and X's that they put on this chart to make sense of the observations that we make. And we figure out, like, we feel pretty good that this pattern held true. The additional surfaces we tested and the things we read in our book match the pattern we had for the things we felt in our schoolyard. And we're like, okay, we think we have enough evidence now to answer our question that the things feel differently because the sun is shining on the sunny places and not on the shady places. So now we're like, okay, how can we think about that? Like, share that, right? Like, we figured something out. We answered our question. What do we do next? So in lesson 5, we're like, okay, we're ready to share with the world. Like, we answered our question. This is great. And we're wondering, like, okay, when scientists want to share something, how do they do that? And we end up using the words cause and effect to help us do that. So the class has figured out that the sunlight is shining on surfaces, the reason they feel hot. And like, now we're like, okay, let's actually name that cause and effect. Because again, it's a big cross-cutting concept in this unit. So the kiddos do a fun card sort where they match up pairs of cards that are cause and effect relationships. There's also a community connection here that I'll talk about in a little bit, but to help them find other cause and effect relationships. And then once they have those words and we're like ready to explain everything, they draw a picture. We don't name it as a model yet, but they draw a picture to explain why some surfaces feel hot and other surfaces feel less hot when they're outside. And then there's this really fun peer feedback moment in lesson 5. This is a putting pieces together lesson. So we want like this nice moment of assessment for the teacher, but the peer feedback helps kids make sure they have everything they wanted to include in their model. So there's the checklist you see there, where it's like, do you have a surface? Did you talk about the sun or the shade? Did you talk about like, is there a cause for that being less hot or more hot, right? And it's a fun time when the kids get to exchange and make sure they have all the components they want in their drawing. So that ends our first lesson set. So then the move for the rest of the unit is to go back to our notice and wonder chart. So in lesson 6, we revisit that notice wonder chart, and we are now pointing out some of the questions we haven't addressed yet. So are there other things we didn't figure out? Well, we were noticing the surfaces like the blacktop or maybe like the rubber on our playground. Some of us, when we had noticed things wonder, we were like, it was like uncomfortably hot. I did not like waiting outside to get into my school when it was hot like that, when the sun is shining on that surface and making it feel hot. This feels like a problem. And so we want to answer some more of those questions, and we get to say, oh, they're like, when there are problems like this, we can solve them. Like, this is something we can do. We name engineering in this lesson, and the kiddos read a newspaper article, the picture of it is there, about a community that is getting ready for a new playground. Their playground has problems. Being too hot is not one of them. They are other problems. But the community identifies problems that they can solve through engineering. And we say, oh, we could do that too. Like, we could find a way to solve our problem of things being too hot, like the blacktop is too hot in our schoolyard. And so we start brainstorming, even right here in lesson 6, we start thinking of ideas we have for how we could make the blacktop less hot. If you don't have blacktop in your schoolyard, it's the rubber or whatever, some other surface in your schoolyard that you want to make less hot. But blacktop is the kind of placeholder term we use in the unit. And the kiddos also do wonderings again, right? So it's our ideas, and now we're continuing to collect our questions about how we might solve, how we might plan, what we might do to enact those ideas. So we've got that list, and we go into lesson 7 then, and we're like, okay, we have ideas. What do we do next? Like, what do we do to carry out our ideas that could solve this problem for us? So we read a book. This is a really fun book. It is not really a biography, but a story of an actual person who designs playgrounds. And we kind of follow her through the process that she uses to interview community members and hear what the problems are that they're trying to solve with a new playground. And it shows the plans that she makes, how she actually like designs the plans for a new playground. And so we're like, great, we can also use drawings to really help us think carefully about what we want to do to solve our problem of the hot blacktop. So in lesson 7, the kiddos work individually to plan their own solution to the problem, the design solution there. You see an example of a kiddo who wrote that's pipe cleaners and cardstock is the way that they want to make the blacktop less hot. And I should say it's sitting in a pan because the kids are introduced to just the materials that they have, and they use a piece of construction paper, black construction paper, in the bottom of like a brownie pan, just an aluminum brownie pan, so that it's a set place for them. This represents our blacktop, and we're going to try to solve the problem here. They combine ideas with a partner in lesson 7. So there's, again, this work of collaboration happening while they put their ideas together. So then we're like ready for lesson 8, right? We've got our plans, we've been able to communicate them. And now we're like, okay, we think we might be ready for the next step. We've got these plans, but what's next, right? We read a book about engineers. So this time we're like specifically around the engineering. What do engineers do when they plan, build, and test designs? And so the book shows us things about how engineers plan and test their designs. And we decide that we're going to build a smaller version. Like, we're not going to be able to build a whole giant thing that's going to actually cover our blacktop. We want to build a smaller version of it so that we can test it. So in lesson 8, they get to build. They have materials provided in the kit. There's a note to the teacher if they want to bring other materials in, that's fine, but there's plenty in the kit for the kids to work with. And they get to assemble. They're working with the same partner that they combined their ideas with in their drawn designs in lesson 7. So yay, we have our things built in lesson 8. Easy transition into lesson 9, which is like, well, now we want to see if they go work, right? So we go outside in lesson 9, we put our designs outside in the sun. We also bring an empty blacktop little pan to bring outside so we can compare and see which designs and materials work the best to keep the blacktop less hot. We do some figuring out. When the kids come back in, they start to do some combining of ideas. You see that chart there that's like, these are the things that we thought caused less hot blacktop, and these are the things that we thought caused hot blacktop. So we start to kind of think about what worked and what didn't work here in lesson 9. And then that brings us to lesson 10, where we're like, okay, we think we've solved it, right? We've got all this test results, and we've got this great chart of like all our test results, and we can combine the ideas that we had from each person's designs that worked and be able to come up with a design that we think is going to be the best. So the kiddos do an individual drawn design again to kind of revise their thinking. And then we use those individual drawings to create a class consensus design. So you can see an example here about what the class decided were the materials and the design features that worked the best to make that blacktop less hot. And then we also get to read the end of the playground designer book in lesson 10. So we get to hear how that playground designer got to share the finished product with the community and how they celebrated that. So we get to talk about celebrating our successful designs as well. I think I get to share a couple key features of the unit. I will just say I love the data analysis. The math connections in this unit are fantastic, and the ELA connections with all the texts that we use and the ways we get to talk about language in this unit are fantastic. But since Janina mentioned those already, I picked different ones to share with you all today. So one of the things that we really love about this unit is just the supports that it has for engineering. So if you maybe back up one more, Janita, I want to make sure we don't skip one. There we go. Thank you. This is the first unit of kindergarten. The field test teachers and students thought it was just so engaging that kids actually get to do this engineering work. They really felt just empowered to do that. And we know that it's super engaging, but we also know that like it's really hard, that engineering is challenging sometimes, right? So one of the first things that we talk about in the unit when we're thinking about engineering problems is contrasting the engineering problems with problems like a kindergartner might experience on a day-to-day basis. Like my sister's not sharing her toys with me, right? So there's like an actual, there's work there around defining an engineering problem that we can solve through building and testing, right? As opposed to other problems we might experience. There are also the unit in all of the Open SciEd K-5 units, we do explicit work around classroom agreements. And so one of the classroom agreements that we support, sorry, I'm still on the engineering one, because it's the classroom agreements really support the engineering work. Specifically the agreement that we're going to let our ideas grow and change, that it is okay that when we investigate things and test things, we're going to find evidence to support new ideas. And sometimes it's going to be that like our thing didn't work, that what we planned and tried didn't actually happen. Like that thing I wanted to build in my drawing is not staying together, right? Or like I put this thing together and it's not actually making the blacktop less hot. So we have some explicit examples of how we can respond when an engineering design doesn't succeed. So the engineering book has some great language around that, because that gives us important information about what doesn't work, right? We learn what doesn't work and then we can try what does work. And then we get to celebrate. There's a community connection at the end of the unit where kids get to take home the 2 drawings that they made and say, this is the first one that I did, and then this is the one I made for my revised design after we learned from the testing and whatever, and they can celebrate that with one of their adults. Okay, now I'm ready for you to slide. Thanks. Another way that we support that agreement of letting our ideas grow and change is with this chart that follows kiddos through the whole unit. And all of our K2 units actually use this. It's called an Our Growing Ideas chart. And it's named as such, right? Because we're going to see our ideas grow and change as we go through the unit. So starting in lesson 2, and then every lesson thereafter, the synthesize moments of the lesson is guided by the kids adding claims about the lesson question and then evidence for how they figured out the answers to their lesson question on this chart. And we try to make it as interactive as possible, that there are visual supports included. There's a printable, like you can cut these things out and have your kids help put them on the chart. Or there's examples here that you can see how we like just drew little sketches to help make this something kids can really look back at and see over the course of the unit. Oh my goodness, we have really figured out a lot of stuff. We're seeing our ideas grow and change. And this chart is fantastic for helping us navigate from lesson to lesson. We know that kindergartners are not going to be doing science every day, or it's unusual if they do. I love it if they do. But even like a lot has happened since in my kindergarten life, since I was at school yesterday afternoon, and I need to remember where we were. Like, where did we leave off? What were we trying to do yesterday? And what do we want to figure out today? This chart is a great navigation tool for that. And for those of you who might be familiar with Open SciEd middle school and high school, this chart is the precursor to the progress tracker that they use in middle school and high school. So it's a whole class thing through third grade. And then third grade teachers have the option to transition to individual progress tracker type thing. That in that case, it's called my growing ideas chart. So in fourth grade and fifth grade, it's a my chart where I'm thinking about my own work and reflections. Okay, last one that I absolutely love about this unit is the opportunities we have for community connections. So there are supports, knowing that we're in kindergarten and we have hopefully adults who are kind of keeping track of what's going on in school and interested in what's happening. We have multiple opportunities for kids to share what they're figuring out in school with their people outside of school, but also for kids to bring in ideas that they know from their experiences and that their families and community can help them figure out back into the classroom. So a couple examples here are the welcome letter that goes home at the beginning of the unit to kind of give adults an overview as to what kids are working on in the unit, and it has some sample questions there to ask your kid to, figure out what's happening and how they can talk about what they're figuring out. And then there are two examples here. The cause and effect examples is where kiddos find and talk about other causes and effects in their day-to-day life. So they can talk about that with another adult. And then when they're engineering and they're trying to think of some ideas for how they might design their structures when they're building, they go and look for other things that block the sun. So they figured out that was one of the things in their model in lesson 5 that was causing the less hot blacktop. So like, we need to block the sun. How do we block the sun? Let's get some ideas. So they go look around with an adult and see what they can find. And just to clarify, these are not considered homework. It's not something that kids need to go do and then have to have back at school. It's not like we're going to grade you on it. You can still totally participate in the work of the class, even if you didn't get a chance to do that with your adults at home. But it's just a nice way for kids to connect the work of their classroom to the community outside the classroom, be able to bring those experiences back and forth. That's all I got. I think I'm ready for questions.
That was great. Thank you so much, Gail. Right. I haven't seen too many questions in the chat. I don't know if we have, we'd love for you to ask some questions in the chat, or if there's been anything in Padlet. Sarah, have you seen anything there?
I've got one in the chat I can answer right now. Does every start to a first, I'm going to say rather than lesson, it's every unit has a welcome letter. Yes. So kindergarten through 5th grade, every first lesson of every unit has a welcome letter, and it follows that same pattern of here's what we're going to do in this unit. Here are questions you can ask and answer with your kids. We try not to give away everything. We want the kids to do some figuring out, but to certainly talk about the practices they're using and the kinds of things they'll be doing.
Right. Other questions? Gail, you were so amazing. There's no questions.
I'm just looking through the chat to make sure we didn't miss any, but you all were great.
Yeah, I don't think I did. I don't think we did. Oh, that's a great question. Is there any sort of front loading or class norms? This is a great one.
I love this question. So every first lesson of every first unit has a it's not really a separate lesson, but it kind of is. There's a teacher reference that's like, here's guidance for setting up your classroom agreements. And it's a way to interact with the kids so that they are helping develop those classroom agreements. And we recommend a place in every first lesson where it seems to fit the best, right? Where like we're motivating the need for those agreements because of the work that we're doing in the classroom. Knowing that elementary teachers often have other things going on in their classroom, they may have already set agreements and set norms. And so we talk about how science is a little bit different. Like, what is the work we're doing in science? And specifically, how might we need to agree to work with each other to get our science work done? And obviously teachers can make connections between those two, but there's guidance for it. If you wanted to do that lesson first before you even started the unit, you could. That'd be okay. It could stand alone. My favorite is when we mix it into like, we're doing this work right now. Oh my goodness, when we're working as scientists, it's really important that we like understand, each other's ideas and thoughts, but there's suggested agreements and there's support for them. And I will just take this opportunity to plug each of the units thereafter. So after the lesson one or after unit one still includes that. Because like Gina said, you might be modular, right? Maybe you're doing the third unit in the sequence for your first unit. So that classroom agreements lesson will still be there. But also, we have different ways to check in on our agreements and revisit them and add to them and expand them based on the work we've been figuring out with each other as the year goes on, so that those agreements are a living, breathing document of like work that we've been doing and how we do that work as scientists together.
Thanks, Gail. Gary has another question in the chat.
Sure.
Can you answer this one? To what extent did the evidence statements influence your unit or lesson design?
Thanks. We look at the evidence statements as we're doing the development of these units as one of many things that we're trying to kind of put together when we're developing the lessons themselves. So they're not the like end all be all. The developers look at them usually just to kind of get some ideas about what this might look like, how this might look, but we're not tied to them specifically. So you're not going to see every single thing exactly like it's listed in the evidence statements, but we do work really hard to support the performance expectations. So in kindergarten, at least for kindergarten through second grade, there are assessment statements that kids are kind of following and that the teacher is watching for assessment opportunities for throughout the whole unit. And those assessment statements are very close mirrors of the performance expectations, so that we're feeling pretty well aligned with the NGSS in that way. Ooh, Marcy. Yeah. Oh, go ahead. Yeah, Amber, go ahead.
Can I just jump in too?
Sure.
I just want to add on a little bit to the question about the evidence statements and just mention that we do look at them, as Gail said, that's one of many resources that we look at. But we also use those to make sure that we're staying within grade band. So we don't want to be going past what is expected of kindergartners or like for other grades or anything like that. So that is another way that we use the evidence statements when informing how we're designing the units.
Thank you for saying that, because that's super important to us, especially in this elementary space. It's really easy to want to go beyond grade band. And we do have each of the assessments and assessment opportunities in the unit has some nice guidance about what to look for and what to listen for to support, that lesson level learning goal or this broader assessment statement, so that teachers have that kind of guidance as well.
Yeah. All right, so Marcy has a question about releases. So Marcy, just to let you know, we are aiming for the first part of the year. Winter is, we are considering winter, February, March, like that time of year is what we're hoping for. We have a date in mind, but we hate to share it and then disappoint someone because we needed another week or two. So just look for it early in the year.
Thank you. Can I answer Linda's question, or I'll try? Do we have a minute?
Oh, that's great.
I just want to address that. Yes, what you saw here was a very expanded version of lesson one. But I also want to echo what Janita said at the beginning, and that is this lesson, the way it's planned out in the teacher guide, we think it'll take about 60 minutes-ish. Depends on how quick your class gets outside. And, if it's the time of year when you need to put on a coat before you go outside and all those things, right? So the lesson is divided into components, And those components are meant to be able to be like kind of dealt out throughout your day, right? You can do the read aloud during your typical read aloud time. You can be doing some of those class discussions during circle time. Take your extra recess time and be doing those observations, so that it is paced in a way that makes sense for your classroom and your schedule. And I think I'm just trying to kind of interpret what you said, Linda, about I sometimes think we go too slowly or do too much thinking for the children. And I want to apologize if I was doing some assuming and some like just repeating of what people were saying. The goal with our science units is that they are very discussion based, in that the kids are going to be able to develop their own ideas through that conversation and through that work together. And the teacher is really there to facilitate it. This is not a situation where the teacher is standing in the front and giving a lecture, right? It is very much the kids interacting with each other and developing those ideas together. And we've heard different things from teachers as far as like, oh man, the first time I do one of these units, it does take a little while. Takes a while for the teacher and the class to be able to kind of get the swing of things. But as folks get more comfortable with the agreements and the kinds of things that we're expecting each other as we do that kind of talking about the science work, it really is nice to like put that lift on the kids, that the kids are able to do the figuring out themselves and not just be learning or hearing about what other people have already figured out.
Yeah. Great. Thanks for saying that, Gail. Because we did give you the quick and dirty version today, the 30-minute version.
Virtual is so hard. I don't know how teachers did it during COVID. How in the world would you do kindergarten on a Zoom call? Like, I don't even know.
Are there other questions, folks? Okay. No, dancing bears, yes. All right, everyone. So I'm just going to give you a couple of things. Please keep putting questions in the chat if you have any more. Just want to let you know that we have a few upcoming events. Next week, we will be here for our 1.1 for our first grade unit. Then the following week, second grade. And for those of you that were looking forward to third grade and were not able to, we were not able to go forward with that meeting last week, we have that scheduled for, I believe it's October 3rd, the following Thursday, after we're all done with everything else. And you can go to register for those on our website, just like you did for this webinar. And we thank you for the